So this question starts off by providing us with this expression here, x squared minus c divided by x minus b. The question goes on to say, in the expression above, b and c are positive integers, so that's good to know. If the expression is equivalent to x plus b and x does not equal b, okay, so first of all, let me just translate what that just said. If the expression is equivalent to x plus b, what does that mean? That means that x squared minus c, right, the expression x minus b is equivalent to, so equals, x plus b. Okay, so if the expression is equivalent to x plus b, which of the following could be the value of c? All right, so I think I'm just looking to isolate c, right? I just want to see what c could equal. I want a c equals something, right? So how would I do that? I would multiply both sides by x minus b to start, because that allows me to cancel out this x minus b on the left-hand side. Again, everything I'm going to do at this point is to get closer to just having c alone. So now I'd have x squared minus c is equal to x plus b times x minus b. And actually here, I think, so of course I could subtract x squared from both sides and then divide by -1 so that I just have a c. But I'm noticing that if I leave this here and I FOIL this, right? This is the difference of two squares, right? So even if we didn't notice what I just said about it being the difference of two squares, if I FOIL this, I'll end up with x squared minus bx plus bx minus b squared, in which case the minus bx and the plus bx cancel each other out. So I'm left with x squared minus c is equal to x squared minus b squared. Okay, so what does that tell me? Well, again, if I have an equal sign, that means both sides of the equation have to be equivalent. I have them in the same format, basically, right? I have an x squared on the left and an x squared on the right, which means, again, I could just subtract x squared from both sides, leaving me with negative c equals negative b squared. And then, of course, I can divide both sides by -1, leading me to have that c is equal to positive b squared. Okay, so now how is that helpful? Well, what do I know about b, right? So if I know that c is equal to b squared, what do I know about b? Well, I know that b and c are positive integers. So if I have a positive integer and I'm squaring it, that means that the output of that needs to be what we call a perfect square. It has to be a perfect square, right? No matter what number I choose for b, if I say b is 1, b is 2, 3, 4, 5, any positive integer you come up with, once you've squared it, it makes that answer a perfect square. So I'm looking for perfect squares in my answer choices, and there's only one. The only perfect square here is choice A, right? In this case, that means b would equal 2, and therefore b squared would equal 4, right? If I tried for choice B, if I said that b squared equaled 6, that would mean that b equals the square root of 6. But b cannot equal the square root of 6 because we're told that b is a positive integer and the square root of 6 is not a positive integer. The same thing works for the rest of these answer choices that we're not choosing, right? Here I'd say b squared is 8, which would mean that b is equal to 2 square root 2. Again, not a positive integer. It's positive, just not an integer. And the same thing for choice D. This answer would mean that b squared, right? Because c equals b squared. Let's not forget that. That's why I'm using b's here. C is equal to b squared. So b squared would equal 10, and that would mean b is equal to square root of 10. Again, not an integer. So that's why choice A is the best answer. It comes down to doing the best we can mathematically with what we have here. But then getting to this stage where, okay, I have this c equals b squared, and that's all I have. There are no numbers to plug in there. So there must be enough information for me to solve this question. I trust that there's enough information for me to solve this question. I go back to the question and I see, oh yeah, b has to be a positive integer, right? And the fact that it has to be an integer is all that I need in order to answer this question.